Okay, we studied Z transform, now we are studying some of their properties. Suppose we are given one sequence x1n and it has got Z transform x1z. In general, ROC will be between two circles, one circle and another circle. That is, if the sequence is both sided, then ROC, I am assuming that Z transform exists. So, therefore, there is some region in the Z plane where capital X1Z exists, and in that case that region is called ROC, region of convergence, and that you have seen will be typically the region between two circles. And if the sequence becomes fully left sided, okay, there is anti-causal sequence, the inner circle shrinks to 0, origin may be included, may not be included. If the left sided sequence starts from the left of origin and goes further to the left, as you have seen last time, then origin is no problem. But if the left sided sequence starts somewhere from the right of the origin and then goes backward, then origin will not be included. Similarly, if the outer circle goes out, then that means the sequence will be right sided. If that includes infinity, that means the sequence starts at either 0 or further to the right and goes to the right. So, that z equal to infinity will not have any problem, but if the sequence starts at any point to the left of origin then goes rightward, then z equal to infinity will not be included. These are all discussed in the previous note, you can see. So, that is why I am saying this is given and we denote the ROC to be mod z, there is r radius r, that is a mod z, less than some outer radius, okay, outer radius, you can call it this outer circle radius and this inner circle radius. Outer circle radius you call R1 plus, this is R1 minus 1 because it is x1. So, this is ROC. Similarly, another sequence is given x2n, it has got another Z transform, its ROC is this region of convergence. Some R2R, there is another region of this kind, that is a kind of ring, annular ring between two circles. Okay, this time here outer radius was R1 plus, inner radius was R1 minus, this time R2 plus, R2 minus. Then if I give you a summation of the two sequence, a linear combination A times x1n, B times x2n, and we call it yn, what is the Z transform yn? So, yz will be summation yn z to the power minus n, and which is nothing but A times so, for y this to exist, mod of this is mod of this, which is less than equal to mod of this is mod of this is less than equal to mod of this entire thing, which is nothing but mod of A times mod of this and then mod of this into mod of this, less than equal to because of the triangle inequality. There was a sum. So, if you apply mod on the sum is less than equal to the sum of two mods, and this mods where you can apply mod of a product is product of mods. So, earlier you had A times the summation. So, if you take mod on the total thing is mod A into mod of the summation. So, mod of this summation, this should be finite, this should be finite, then right hand side is finite, then DTF y Z transform yz is bound to exist. It is a sufficient condition, I agree, but in terms of sufficient condition also only, what will be the new ROC? It should be such that both this becomes finite, this remains finite. Mod A, mod B, they are already finite. So, if it is finite for any z, then this is finite, summation finite, mod yz for your chosen z is less than equal to something finite, which means mod is finite. So, yz exists because its magnitude is finite. Therefore, ROC of yz should be what? It will be such that this is finite, but this is what? This is the mod of the Z transform of x1n. This will be finite in the ROC of capital X1z, because after all this was the Z transform of x1n, I am taking mod of that. This we have seen in the last class. This mod will be finite if I am picking z from the ROC of capital X1Z, where it is defined. And again this will be finite if I am picking z from the ROC of X2Z. But for this right hand side, there is only one common z. Therefore, if this ROC and this ROC, they have some intersection, there is overlap, common area, then from that I should pick z. For that z, this will be finite, this will be finite, because that z is part of the ROC of this, part of the ROC of this. So, then right hand side will be finite. For instance, if there is an overlap like that, then okay, this is one annular ring, this may be RO1 minus, this may be RO1 plus. And suppose you have got another case, okay, this may be R2 minus, this may be R2 plus. So, you see in one case you have got this green, between these two green circles there is one region, that is the ROC for this guy, this, and between the two red circles R1 minus R1 plus, you have the ROC of this guy. But there is an intersection, there is an overlap, common area between the two, and this common area is from this inner green circle to the outer red circle, this is the intersection between the two ROCs. Okay. So, if I call this as ROC1, if I call this as ROC2, ROC1 is the area between the two red circles, ROC2 is the area between the two green circles. Now, if they have some intersection, they overlap, that intersection inside theoretic notation we denote as intersection ROC2. If there is an area of intersection, then this will be the ROC of YZ, if it exists, and in that case YZ will be nothing but A times X1Z and B times X2Z, because if you know that YZ will exist, there is its mod will be exist finite. Okay. In that case, if you take Z transform YZ Z to the power minus n summation, that is same as A X1n Z to the power minus n summation, which is A capital X1Z, plus B X2n Z to the power minus n summation, which is X2Z. So, B X2Z, because the X1Z also is existing, X2Z is existing, because I am picking Z from the intersection between the two ROCs. Okay. Therefore, for that Z, this is existing, so the summation exists, and there is your YZ. So, ROC of YZ will be intersection of the two ROCs, and in that case, if this intersection exists, if there is no overlap, then there is no ROC for YZ. So, Z transform does not exist for YN. So, such overlap must occur. If there is overlap area between the two ROCs, ROC1, ROC2, then that will be the new ROC of YZ. You should pick Z from there. For that Z, X1Z also exists, X2Z also exists. Therefore, if you take the Z transform of YN, that is summation YN Z to the power minus n sum, it will be A into summation X1n Z to the power minus n, that will be existing. So, you can call it X1Z, plus B into X2n Z to the power minus n, that will be existing, its mod will be finite. So, it will be just summation of the two. Okay. This is one property. Number 2, convolution. Suppose x n has got Z transform some or x, because it is coming to x, or x plus or x minus. This I call ROC x for x n, and there is another sequence H n, its Z transform is H Z, its ROC is general ROC or H plus or H minus, which I call ROC for H. Now, suppose I have got a convolution y n. As I told you, I always prefer to write convolution this way, H r x n minus r It does not matter here though, either way is fine. So, Z transform of yn, that is yz, assuming it exists, it will be assuming it exists yn z to the power minus n minus infinity to infinity, yn you replace by that. What is this hr x n minus r from minus infinity to infinity, z to the power minus n. Then two summations, interchange the two summations. There is the next step, r summation goes out, summation over n goes in. So, all quantity which is a function of n, they should be inside. So, x n minus r, this is n, so this should be inside, z to the power minus n, it will be inside, hr can be common as outside. Okay. Z to the power minus n, suppose I make it minus n minus r, because r is, every time you pick up one r from outside sum, h of r, then into you run this summation for that r, n varies from minus infinity to infinity, okay, but r is constant in this sum. So, z to the power minus n minus r, if I bring, that means I have brought an extra term, z to the power minus minus plus, that is z to the power plus r. So, I should cancel it by r, z to the power minus r, but again this does not depend on n, this depends only on r. So, this can go out of the summation as a common term. So, I can push it here. So, this summation now n minus r you can call m, which means this will be now n minus r is m, r is fixed. So, if n goes to plus infinity, m goes to plus infinity. If n goes to minus infinity, m goes to minus infinity. So, x of m z to the power minus m. Now, this summation, if this exists, then this is the z transform of x. So, this we can take common and it goes outside the summation, and then that is capital X z will go out here, and then you have the inner summation, this h r z to the power minus r, this is again z transform of h, assuming it exists. So, it will be capital H z. So, if z transform here exists, that will be just product x z h z. But for that, this should exist and this should exist, that is mod of this. In fact, if you take down mod of this everywhere, mod of this, finally mod here, mod of a product, and therefore, mod of this, and mod of a product is mod of the. So, this should be finite, this should be finite. Okay. This should be finite in the ROC of x z, this is finite in the ROC of h z. If the two ROCs have some overlap like the previous example, then that overlap area will be the common ROC for y z. I should pick z from there, and there the z transform of y n, capital Y z will be product of the two z transforms. That is y z, as we have seen before applying mod here, it was x z, h z, and ROC will be ROC of y will be intersection between the two, ROC x as before, because this must be existing, but this exists only here, and this also must be existing. There is more, this should be finite, this should be finite, this is finite here. So, both should be satisfied, means this one should be satisfied, this also should be satisfied. So, the two ROCs, if they overlap, there is an intersection like my previous diagram is the intersection common area between two ROCs, that is between two red circle one area, between two green circle one area, one ROC, and their common area is this shaded part. If such overlap or intersection exists, then that will be the ROC of y, and there if I pick up z from there, then y z will be x z with h z. But if there is no such overlap, then y n does not have a valid z transform. All right. We are assuming that such an ROC exists, that is the two ROCs overlap, and therefore, y z will be x z into h z in the intersection part of the two ROCs. All right. This is one property. Then suppose x n has got z transform x z as before for mod z r plus r minus. In general it is between two concentric circles, the annular ring between two concentric circles. Inner circle can go down to 0 or outer circle can go out to infinity, as special cases that you have seen. This is given. Now, if I have x n minus r, it is a delayed sequence, you can call it g n. What will be g z and what will be the ROC? What will be the ROC of g? This is ROC of x. What will be the ROC of g? So, fine. Suppose g z exists, that is mod for some z in the z plane, its g z exists, that is mod of g z is finite. Suppose in that case I can write g z is this summation, same formula, z to the power minus n, and now bring back g n is equal to x n minus r. Sorry, z to the power minus n, but I make it z to the power minus n minus r, that is I bring an extra term z to the power plus r. To cancel it, I have z to the power minus r, but summation is over n and this does not depend on n. So, this entire summation can be here and this can go out as a common, and now you call it m, if n goes to plus infinity, m goes to plus infinity, because n minus r is m, same sign. If n goes to minus infinity, m goes to minus infinity, which means it would be a summation all right, r was the delay. So, this is nothing but z to the power minus r x z, but only thing is I am assuming this is existing, that is its mod will be finite. For the mod to be finite, it is a product, mod of the product is mod of z to the power minus r into mod of x z. So, this should be finite, but this is finite over this ROC x, and this should be finite. Now, if suppose the sequence is both sided, okay, from minus infinity to infinity, then the I know that ROC will be between two circles. So, the case of z equal to 0 or z equal to infinity will not arise, because it is between two circles. So, z to the power minus r, suppose r is positive. So, z to the power minus r, if z is 0, 0 to the power minus, there would be a problem, it will not exist, but z equal to 0 does not occur in this case. Similarly, if r is negative, that is g n is x n plus something. So, it will be z to the power minus r, but r is negative. So, it is a positive power of z. In that case, z equal to infinity would have created a problem, because this would have gone to infinity, that means this would not have existed, but that is ruled out in this case, because z equal to infinity is not allowed, only this area is allowed. So, here for this kind of cases, ROC remains as before, ROC of g z is same as the ROC of x. Okay. But suppose I have a sequence which is purely right sided. Suppose you start from here, somewhere here, purely right sided. In that case, and you are starting from here, in that case, we have seen ROC will be, ROC of x will be like this, outside a circle, and it will go up to infinity. Okay. It will go up to infinity. So, in that case also ROC will be, ROC of g z will be where, in the area where mod x z is finite, that means ROC of x, which is starting from this circle, some circle and going up to infinity, and this also is finite. So, if this sequence starts at some point to the right of origin, goes to the right, z equal to infinity is not a problem. Okay. And z equal to 0 will not occur, because I am going outside the circle. So, this will be existing, because even if we put z equal to infinity, if r is positive, suppose, okay, then negative power of z, and even if z is infinity, this will exist, and z equal to 0 will not occur here, because I am starting from a circle and going out. So, in this case again Gz will have the same ROC as Xz. Suppose it is right sided, but you are starting from left of origin and going to the right, and R is say positive. These are various cases. In that case, we know ROC of Xz will be starting at circle, some circle, and going up to infinity, but not including infinity. That is the ROC of X. And if you do not include infinity, then this thing, this fellow z to the power minus r, okay, this will not create any problem. In any case, r is positive, even if r is negative, this will not create any problem, because infinity is not allowed. Okay. So, likewise, you will see that ROC will be same as ROC of X. Okay. Here, if this is the sequence, ROC of Xz will start from a circle and go up to infinity, but not include infinity. So, that is ROC X. In that region, so ROC of Gz should be such which is overlap of the ROC of this and ROC of this. Now, ROC of this is starting from a circle going up to infinity, but not including infinity. In that zone, if I pick up any z from that zone, there is neither infinity not 0, and this will have no problem. Even if r is negative, r is negative, so z to the power plus some positive power, even there is no problem, because z equal to 0, z equal to infinity is not coming. So, ROC of Gz will be same as just ROC of this. Okay. Any z you pick up from the ROC of Xz, this also be finite there for this sequence. Okay. Earlier also you have seen, if you start from here and you start from here, okay, and r is say positive, then again this will be finite even if you put z equal to infinity, and this ROC will go up to infinity, will include infinity. Okay. So, this will be finite, because even if you put z equal to infinity, this is negative power of z, no problem with that, and z cannot become 0 because you are starting from one circle. So, a whole ROC of Xz, if I pick up any z from there, this also will exist there. Therefore, there also ROC of Gz will be same as that of Xz. But suppose we consider this case, you start like this, okay, and this is x n, purely right sided, but its ROC will be again outside a circle and is going up to infinity. If r, this shift is negative, if shift is negative, it will be shifted to this side. So, in that case, again to find out the ROC of Gz, you have to first see the ROC of Xz and the region where this exists and intersection of the two. Now, ROC of Xz is outside a circle going up to infinity, and once again if I pick up any z from there, bring it here up to infinity. Okay, if the problem is infinity cannot be included there now, because if r is negative, infinity to the power positive power, that would have come. Okay. In this case, I am taking up to infinity, but z to the power minus r, if r is negative, okay, then z to the power minus means z to the power positive r, some positive value. So, z equal to infinity will not be allowed, okay, even if ROC of Xz includes infinity. So, these are the things that we seen depending on where the sequence starts and all that. All right. Now, so we have seen convolution, we have seen delay, shift, and now suppose you got a rational system. Yeah, but before that something more. Suppose there is a causal sequence H n, causal. That means H n equal to 0 for n less than 0. So, H z, so it is a purely right sided sequence. So, H z will be, we have seen for purely right sided sequences, ROC will be outside a circle and will go up to infinity. Okay. So, if it is a causal sequence, Z transform will have of causal sequence will be having region of convergence starting from a circle and then going up to infinity. Okay. Stable. Now, what is the stability condition? If H n is the impulse response of a linear shift invariant system, it is summation but for Z transform H z to exist, there is mod of which is less than equal to mod of a summation less than equal to summation of mod, and mod of a product is product of the mod, and if you take this, it is r to the power minus n. Okay, so minus infinity infinity, not necessarily causal, this thing. Okay. So, suppose r is 1, that is r equal to 1, for that also if it is finite, that means I will say ROC of H z includes r equal to 1, that is r equal to 1 means a circle of radius 1, it is called unit circle in the z plane. So, if the ROC of H z includes ROC of H z as such is, if it is both sided, it will be between two circles, okay, between two circles. But if it is like this, one is inner, one is outer, and this is the ROC of H n, but it includes this r equal to this unit circle for which r is 1. Then what will happen? This right hand sum just becomes, and I am wanting, if it is part of r equal to 1 is part of ROC, that is this circle is part of ROC. So, if you put r equal to 1, this summation also should be finite, which is same as this condition. This was the stability condition, and here I was just approaching ROC, region of convergence of H z. So, I took out the summation of H z, applied mod over that, and mod of this is less than equal to summation mod H n r to the power minus n. So, if H z is to exist, mod of H z is to exist, that is, if you are considering the ROC, region of convergence of H z, that is, I am picking z from the ROC of H z, where z is in general r into to the power j omega, then for that r, if I have this summation, this should be finite. Now, I say, suppose r equal to 1 is part of that ROC. If r equal to 1, this summation becomes this, but r equal to 1 means in the z plane, it is a circle of radius 1, which is called unit circle. So, if unit circle is part of the ROC of H z, that means on the unit circle also this mod of this, I mean this will be finite, but on the unit circle r is 1. So, this will be finite, but this condition and this condition are same. Therefore, the system will be stable if ROC of H z includes unit circle. If it is causal, it starts from R, ROC starts from some circle and goes outside up to infinity, including infinity. If it is stable, ROC, wherever it is, should include unit circle. Okay. Now, there is a relation of this with, if you go for an linear shift invariant system, impulse response H n, but it is also rational. It is given like this y n Suppose we do not know whether it is linear or shift invariant, just this equation is given. If we take Z transform on the left hand side, we take Z transform on the right hand side, they will be equal. This will give rise to y z, then A 1 Z inverse y z I am assuming that Z transform of all of them and all of them have some common area of intersection, the ROC of yz, ROC of yn minus 1, okay. ROC of the Z transform of yn minus 1, ROC of the Z transform of yn minus p for x, all have some overlap area. I am picking Z from there. So, all of them exists. So, it is Z inverse, it is Z inverse p, and this side is b 0 x z plus b 1. I have seen already, if it is x n minus r, then Z transform becomes Z to the power minus r into original Z transform. So, r is 1. So, Z to the power minus 1 original Z transform x z, like what I have done here. Y n had Z transform capital Y z, y n minus r is 1. So, Z transform, if it exists, it will be Z to the power minus r, that is Z to the power minus 1 into original y z. If it is n minus p, it will be Z to the power minus p original y z. Similarly, here. And then if you take y z common, x z common, this ratio will be now, if initial conditions are given to be 0 for this equation, then I know the system will be linear and shift invariant. And in that case, output y n and input x n, they are also related by a convolution relation between x n and h n. And in z domain, y z is x z into h z, or y z by x z, in that case will be h z. If the system is linear and shift invariant, that is this equation which has been given with 0 initial condition. So, in that case, h z becomes like this: ratio of two polynomials, numerator in terms of z inverse, powers of z inverse, a polynomial in terms of powers of z inverse 1, z inverse 2 dot dot dot, denominator also. Okay. From this transfer function, this is called a transfer function. Concept of pole and 0 will come. Suppose this denominator polynomial z to the power minus 1, suppose I call u. So, it is 1 plus a 1 u plus dot 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 a p u to the power p. You can factorize it in terms of in this manner, 1 maybe minus some coefficient, say alpha 1 u, 1 minus alpha 2 u dot 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 1 minus alpha p u, all first order factors. This is fundamental in algebra. So, if you multiply them 1 into 1 into 1, you will get 1, there will be some term like u with some coefficient, another term u square like that. So, you can factorize, and then u means z inverse. So, 1 minus alpha 1 z inverse dot 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 dot. Same you can do in the numerator. So, this you can write as but numerator I leave it as it is. Numerator polynomial I call it n z. N for numerator is a function of z. So, instead of writing the full expression, I just write n z. But denominator I factorize. So, it will be alpha 1 u now. What is the root of this? U equal to 1 by alpha 1. Okay, 1 by alpha 1. What is the root of this? U is equal to 1 by alpha 2 dot 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 dot. So, this function in the denominator, they have got p factors. Every factor gives us to one root. If you take u equal to that, this factor becomes 0. So, there will be a division by 0, this means this will shoot up to infinity. So, this function will not exist. So, therefore, ROC of h z, but otherwise if you take u and u is z inverse, you can directly write now. Okay. So, z inverse was alpha 1, u is at what point, at what value of this will be 0, alpha 1 into Z inverse equal to 1. Okay. Alpha 1 Z inverse equal to 1, which means Z equal to, if you take this Z inverse means 1 by Z, if you take that to the right hand side, alpha 1. So, at Z equal to alpha 1 into alpha 1 inverse cancels, become 1, 1 minus 1, 0. So, at Z equal to alpha 1, this function, this factor is becomes 0, and overall function does not exist because it amounts to division by 0. Then Z equal to alpha 1 will be called a pole. Okay. Similarly, Z equal to alpha 2 will be called a pole, because at Z equal to alpha 2 also this factor becomes 0 and the function overall thing does not exist. Similarly, at Z equal to alpha p. So, I have got p poles, Z equal to alpha 1, alpha 2 dot 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 alpha p. So, if Z takes values other than them, then each of the factor exists, Nz also exists, the whole function exists. So, if you are given a form like this, a transfer function, you are given a form like this, a numerator polynomial in Z, denominator polynomial in Z. Then you find out, you do carry out factorization in first order factors of the denominator. You get these poles alpha 1, alpha 2, alpha p. You now know these poles cannot be part of the ROC of Hz. So, if I am trying to have an ROC of Hz in the Z plane, that ROC must not include alpha 1, alpha 2 up to alpha p. That is, suppose, okay, forget this. Suppose you have got just alpha 1, alpha 2, alpha 3. So, this alpha 1, this alpha 2, this alpha 3. Suppose I draw a circle through this, another circle through this, and another circle through this. Then you see this region can be one ROC, because neither alpha 1 nor alpha 2 nor alpha 3 exist here. So, Z is neither equal to alpha 1 within this circle, inside this circle, neither equal to alpha 2 nor equal to alpha 3. So, for any Z here, these factors, none of these factors will become 0, 3 factors in this example. So, this overall function Hz will exist. So, this qualifies for one ROC. Then this region, this neither carries, I mean neither has alpha 1 nor alpha 2, because it is a region between the two circles, it does not include the circles. So, Z is neither equal to alpha 1 nor equal to alpha 2 nor equal to alpha 3. That is one possibility. And again this is another possibility, and outside the circle is another possibility. Now, if it is this first possibility inside a circle, now if it is inside a circle going up to 0, you remember what should be the corresponding sequence in the time domain? It will be a left sided sequence, and that starts either at 0, okay, or starts from left side. So, Z equal to 0 is not a problem. So, either from here or from here or from here, and goes down like this, okay, at this side 0. So, we call it anti-causal sequence. If it is here, then it is an annular ring between two circles. So, that means that will be both sided. If it is here, if I take ROC to be this, that is another valid candidate for ROC, because Z is neither alpha 2 nor alpha 3 nor alpha 1 within this. That is one valid ROC. So, in that ROC, again it is a region between two circles, annular ring, there is region between two concentric circles with center or origin at center. So, again that will be another both sided sequence. And if I take this outside this grid circle area up to infinity, that will be again another valid ROC, but this time it will amount to a sequence which is purely right sided, because I am going outside a circle and going up to infinity. So, it can either start here or it can start further from right, from right of the origin, either like this, or you can even start from here and right sided. You cannot start, I mean, so it is causal. Okay. Now, if the system governed by this transfer function is to be causal and stable, for stable we know ROC must, for causal it should start at a pole, furthest pole from the origin, furthest pole in terms of radius magnitude. If you take this is the this much is the magnitude of alpha 3. Alpha 3 is a complex value. This is the magnitude, this is the angle. So, this much is mod alpha 3, this much is mod alpha 1, that much is mod alpha 2. So, you take that pole which has the maximum magnitude, that pole will be furthest from the origin. Now, draw a circle through this, go outside. So, this outside region cannot contain any of the pole. Okay. If I take that to be the ROC of Hz, then that will amount to a causal sequence in time domain, because it is starting from one circle and going outside up to infinity. So, in that case I will get a causal sequence, not when I take the ROC between these, because then the sequence will be both sided, not causal, not when I take it here, then again it will be both sided, not when I take it here where Hn will go to the left side. For causality, Hn should be 0 for n less than 0. It should start at n equal to 0 and go up to infinity, then it is causal, but the corresponding ROC will be outside a circle. That is possible only if you take this pole farthest from the origin and draw a circle and then go out. Then this region cannot have any pole, that is another valid ROC, but that is outside a circle up to infinity, that is the only way. So, if I take that ROC, my this thing sequence in time domain, that is if I take the inverse transform, inverse jet transform of that, if I get Hn, that will be causal. Stability, for stability I have told that ROC should include unit circle, that is circle of radius 1. So, this ROC outside this circle should contain an unit circle. Unit circle means radius should be 1. So, this ROC which starts from the grid circle and goes outside up to infinity, this should include this unit circle, which means every pole should be within unit circle, and then you take the pole which is farthest from the origin, draw a circle through that and take the ROC to be the area outside that circle. So, that will be outside a circle up to infinity. So, the corresponding sequence will be causal, right sided, and that includes unit circle, therefore, that will be stable, which means for stability and causality, poles of a rational system must lie, all the poles within a unit circle. Okay? That is all for today. Thank you very much.